I think Mott needs to get new boilers. Don't get me wrong, I love making videos. Always a good time. Just feel like, it's more productive to be in a warm room together instead of being, separated. With you over there and me here at this cluttered desk, surrounded by papers, pens, cans, and ginger beer that's probably as old as Mott's boilers. But we will be just fine. There is math to be done, and we're gonna do it. To us. Truth be told, we're actually making really good progress. So I don't want to go into a whole lot of new things today. I just kind of want to finish up the conversation that we had started yesterday. But that does beg the question of, what conversation did we start yesterday? What did we do last time? And yeah, I'm still going to ask you that question and give you a minute to think about it. Write it down and don't use your notes. And I'm going to go get a new ginger beer. My last one. Make the most of it. What did we do last time? Let me tell you. We started talking about arguments and a valid argument and what makes an argument a valid argument. Remember that an argument is just a conditional of sorts, right? I've got this huge premise that's all of these different statements put together, and we're saying that when all of the premises are true, the conclusion is also true. I actually left off on a try it with a buddy, so I want to look again at that one. We had left off on this try it with a buddy question, where I gave you this argument to examine. The water is cold, or I will not drink the water. The water is cold, therefore I will drink the water. Now keep in mind, my first goal here, the first part of this process, is to write my argument in its symbolic form. And for that, I'm just gonna read through it again and look for the individual statements, the pieces that make it up. And here I'm seeing really just two statements or phrases that are making it up. I see the water is cold, and I see I will not drink the water. Everything else is made up of those two. So those are the ones that I'm going to give names. I'm going to say W is the statement, the water is cold, and I'm going to say D is the statement, I will not drink the water. Now you could just as easily say that I will not drink the water is not D, and that'll work fine for you. For the sake of this example, I'm going to say that D is the statement, I will not drink the water, just because I feel like it makes our setup a little bit more straightforward. Now, I've got these two statements. Everything is made up of these statements. Everything in my argument is a combination of either W or D or not W or not D. Everything just comes from those. So I want to write my argument in its symbolic form now. Let's read through it again and put those together. The water is cold, that's W, or I will not drink the water. That's not an if-then. It's an or. So the first part of my argument is W or D. The water is cold, or I will not drink the water. Lovely. Second is just this sentence. The water is cold. That's just straight up W. No changes made there. And then finally, therefore. That's my key word saying I'm looking at a conclusion now. So I'll say, therefore, I will drink the water. That's not D, right? I will drink the water is the negation of my statement D, that I will not drink the water. Now that I've got my argument in its symbolic form, I can create a truth table to examine whether or not it's valid. Let's have a look. I've only got two statements, W and D. So as I'm putting my truth table together, I'm just going to have 4 rows for the 4 different possible truth value combinations of those two statements. Remember, if the W and D are throwing you off and you feel more comfortable with P's and Q's, that's fine too. You could just say that P is the statement, the water is cold, and Q is the statement, I will not drink the water. Regardless of what you're naming them, my first 2 columns are always going to be the collection of all possible truth values, no matter what the statements are. In this case, I've got W and D. Before I even look at premises and conclusions, I'm setting this up to look at all possible truth value combinations. Keep in mind, my goal is to make sure that whenever all of the premises are true, the conclusion is also true. In order to have that conversation, I need to be able to look at when are my premises true. And for that, I need to be able to look at everything that could happen, so I can talk about when that happens. One of the reasons that I wanted to make my statement D to be I will not drink the water is that sometimes I see people get tempted to make this second column not D. That doesn't exactly fly. The point of the truth table is to talk about when things are true or false in regards to the 2 statements involved. And my 2 statements are W and D, not W and not D. So I'm going with W and D, and let's have a look at these premises. W or D. When is an or statement true? It's true when at least one of them is true, right? So that's going to be all these 3 rows, and the only time it's false is in this bottom row, when W and D are both false. My next premise is just W, which I already have a column for, but I'm going to go ahead and write another column for it, just because I like having my premises together. Nothing really to calculate, I'll just rewrite this column again. And now my conclusion is not D, the negation of D. So I'll create a column for not D and flip all of the truth values around for it. Every true becomes false, every false becomes true. And now I'm able to look at whether or not this is a valid argument. I want to look at all of the rows in which all of my premises are met. I had only 2 premises, this one and this one. Their columns are here and here. I want to find all of the rows in which these columns, my premises, are true. That happens twice. It happens in my first row, and it happens in my second row. These are just a means to an end over here. They're telling me all possible circumstances of W and D. And this is going to be my conclusion. It's going to be all the things that I'm looking at to determine if it's valid. But these are the premises. My goal is to look at when all of these are true, is my conclusion also true? Well, now I've looked at when all of these are true. It happens twice. It happens in this row and it happens in this row. Now I want to look at the conclusion. Is the conclusion also always true whenever these are? Well, it is in this row. Works out great. But not in the first row. It is false here. So this is an invalid argument. I can't say that this is valid. It's not the case that whenever all of these are true, that this is also true. It might be, but it might not be. But the promise of an argument is that I can always reach that conclusion, no matter what. As long as these things are true, this would have to be true. And that's not the case. So this is an invalid argument. That's what we had done last time. And I want to just keep that conversation going a little bit. What if we've got more than just 2 individual statements that are involved? What if we've got like 3? What would it look like then? Well, it gets a little bit bigger for a couple of reasons. One is that if I've got more than just 2 individual statements, then I'm going to have more than 4 rows. You know, every statement doubles the total number of rows that I get. You get 3 individual statements that are making up my whole argument. Now we've got 8 rows to consider. You give me 4, and now we're up to 16. 5, and I get 32. So these could get big quickly, and I don't want to do any examples that get really big. I'm just trying to get the point across. But you can see how they would get big. The other way that they can get big is that as my argument grows, right, as I get more premises, I have more things to consider. And as my premises get more complicated, it might take me a few columns of a truth table just to work out what one premise is. Again, my goal is not to get to that level of complication, but I do want to show you what a slightly bigger argument might look like. Have a look at this one. Yeah, that's way better. Take a gander at this. Here's the argument: if I jump in the lake, my clothes will get wet. If my clothes get wet, I will be uncomfortable driving home. Therefore, if I jump in the lake, I will be uncomfortable driving home. This argument isn't much bigger in terms of premises. There's still only going to be 2 premises and 1 conclusion, but I do have 3 individual statements that make it up. Let's read through this and identify them. If, okay, that's one of my key words for like an if-then. I jump in the lake. All right, we'll give that a name. I'll call it J for jump in the lake. My clothes will get wet. Okay, that's new. I'll call that C for clothes will get wet. If, okay, another if then, my clothes get wet. Oh, I've seen that one before. That's C. Cool. I will be uncomfortable driving home. That's new. I'll call that U for uncomfortable driving home. Therefore, conclusion time, if I jump in the lake, sounds like C, not C, J. If I jump in the lake, I will be uncomfortable driving home, which is U. Alright, so I've got my whole argument here seems to be made up of these 3 individual statements, J, C, and U. My argument starts with, if I jump in the lake, then my clothes will get wet. That's J implies C. If J, then C. My second sentence is, if my clothes get wet, then I will be uncomfortable driving home. Well, that's another implication. C implies U. Therefore, my conclusion now is, if I jump in the lake, I will be uncomfortable driving home. Notice that my conclusion is a conditional. I'm reaching the conclusion that this other conditional must be true. Assuming these other conditionals are true, the conclusion that I'm reaching is not one individual statement. I'm not concluding that I will jump in the lake, that my clothes will get wet, that I will be uncomfortable driving home. My conclusion is another if-then. I'm able to reach the reasonable conclusion that if I were to jump in the lake, I'd be uncomfortable driving home. Is that valid? Well, I got 3 statements to worry about now, J, C, and U. That means I've got 8 different truth value combinations to consider. However you get to these 3 columns at the beginning of your truth table is up to you, whether you're following the tree method that I showed you or following the pattern of trues and falses. This is the collection of all 8 possible truth value combinations. And now I want to examine those premises. J implies C. Okay, my first premise here is this conditional. J implies C. I know when a conditional is true, and I know when it's false. The conditional is true as long as the conclusion is true, whenever the hypothesis is true. The only time it's false is when you have true implies false. So I'm going to have true implies true is true. True implies true is true. True implies false is false. True implies false is false. And the rest of these are all going to be true because my hypothesis is false the whole time. Same deal for my other premise. C implies U. Now I'm just looking at C and U. Same deal. If C, then U. True implies true is true. True implies false is false. These will both be true. The only other false that I get is the true implies false right here. And all of the others are true. That just leaves me with my conclusion, J implies U. So that's J and U. True implies true is true. True implies false is false. True implies true is true. True implies false is false. And then the rest are all leading with false, and so I can't be wrong, right? Anything goes. And so all of those will be true from there. That is my premises and conclusion, so I'm in the spot now where I can examine whether or not this is a valid argument. These two columns are my two premises. And remember, an argument could have more than two, but all of our examples have only had two premises here. I want to find all of the rows where both of my premises are true. It actually happens 4 different times for us. It happens in the first row, it happens in the 5th row, it happens in the 7th row, it happens in the 8th row. 4 different times that all of my premises were met. And I want to look at the conclusion for each of those 4 times. If there's even one time where it's false, then this is an invalid argument. But it works in the first row, and the 5th, and the 7th, and the 8th. It works all 4 times. Every single time that my premises are true, my conclusion is also true. So this is a valid argument. It does exactly what it's supposed to do. That's actually all I really wanted to go through with you today. Thought it might be nice to finish up some of those examples, do one more with you. I do want to give you one more question to look over and practice while we're apart. And I really want you to do this, practice it, either work through it on your own or try it with a buddy. If you have a buddy nearby who's in this class or knows formal logic, they're welcome to chime in. But have a look at this one. Here is the question. I want you to examine whether this is a valid argument. If my ginger beer is spoiled, then I will not drink ginger beer. If I drink ginger beer, my tummy feels better. Therefore, if my ginger beer is spoiled, my tummy will not feel better. Take a look at that one on your own with a buddy. Determine whether or not it is a valid argument, and reach out to me if you have any questions. Have a great day, and I'll see you later.
Silent treatment ain't no cure, just making it harder. Keep on acting busy on your phone. I just wanna feel your touch, baby, can we stop this? Don't you wanna hold me anymore? Arguments spinning in circles, we're fighting for days, stuck in a phase. I think we're losing the